Okay, let's finish the high frequency effect, the phenomena of high frequency on this amplifier. So basically we can say that when the frequency of the signal, this f, okay, increases, so by this relation when f increases, right, so your xc would go down, it decreases. So when xc decreases, so you can see this one, the c1 over here, this c1 can be effectively xc when it decreases, so we can assume this as to be 0, right? Okay, similarly c3, we assume this xc3 equal to 0. And similarly, okay, for high frequencies, okay, for an increased in much increase in frequency, we can assume this xc equal to 0. So this is the same thing assumption we studied in the previous chapters. But when this occurs, actually what happens that is when this occurs, so though these reactances can be ignored, okay, c1, c3 and c2, but there is a formation of internal junction capacitance between the base, the collector cbc, between the collector and base, and over here. Now we can see this, what would happen that now with the formation of this path, okay, so now this is, previously it was open, okay, now it is short, okay, so it is like relatively a low reactance path, okay. So what would happen that if a signal comes in the collector, okay, if a signal is in the collector branch, you can see, so it can readily goes, okay, through the base through this path. So what would happen that a signal coming from the base, okay, it would distort, this signal would distort this signal, okay, and there occurs a voltage drop, okay, at the base. So the net, okay, so the net effect would be the voltage reduction in the voltage gain, because if this signal distorted this incoming signal, so basically the magnitude of signal at the base, the net signal over here, it would decrease, and this will result in the reduction of the voltage gain. Similarly, it can produce a phase shift as by a default characteristics of RC circuit, and we will be studying that later on. So anyhow, going further into the slides, so now okay, we defined this decibel, and we defined decibel is to express the amplifier gain. So this is a voltage gain decibel. Okay, when we define when we have a voltage gain, so the decibel is readily defined by taking log of the voltage gain into 20. And if we have a power ratio, so the power ratio can be done in the decibel, it can be converted into decibels by taking the log and multiplying it with 10. Okay, now this is a small example. It says they express each of the following ratio in dBs. So you have a power, and then voltage. This is also power, this is also voltage. So we can apply these formulas, right? Okay, so let me show you some of, if I go to the calculator actually, and if I open the calculator, so we can say over here, if I do this one, if I solve this part, so taking log of this is, so I can say 250, okay, when I take the log of 250 and multiply this with 10, so basically the result would be 23.97, which is almost 24. So this is the result. Okay, let's suppose if I solve a voltage ratio, a voltage gain, so this is a voltage gain over here. Okay, the C I would like to do with the E. So this is a voltage gain. So for the voltage gain, I would say 0.707, 0.707, and then take the log, okay, multiply with now 20, because this is a voltage ratio, so the answer would be -3. Okay, so this occurs at minus, the value for this voltage is -3 dBs, so this is -3 dBs. Now what we do over here, basically we can say over here, if I coming to this graph now, Now this is a typical graph between the frequency and a voltage gain, right? So now the y-axis shows a voltage gain, but if you see, the y-axis has a negative values of the voltages, and it is expressed in dBs. Why? Because of the fact that we are studying frequency response, and we know that when the frequency response results in the reduction in the voltage gain. So that's why the reduction is denoted by these negative values, and this is the x-axis is the frequency axis. Now we want to define some parameters on this graph. Now the first parameter on this graph is let's suppose okay, the critical frequency. First of all, we talk about the critical frequency. So the critical frequency is known as also known as a corner frequency, and it is a frequency at which the output power drops to 1/2 of the mid-range value. Okay, now this is a point over here. Now this is a point which is, we call it a critical frequency point. Now okay, and this is an area where your f is increases, okay, as seen in by this axis, and this is area where your f is decreases, f frequency of the signal, input signal, it decreases, and this is in a value or a point, which we known as a threshold value, or a corner value, and this basically differentiate between the high frequency and the low frequency, and this is the cutoff frequency. Now the property of this cutoff frequency is that at this frequency, at this particular point, there will be a drop in 3 dBs, in the voltage gain. So over here, if you see, it was initially 0 dB, but at critical frequency, the voltage gain was dropped by 3 dBs. So this is known as, by definition, a critical frequency is that frequency where your power gain is reduced by 3 dBs, and this corresponds to 0.5. This the ratio is 0.5. And when you talk about the voltage gain, so again, if this is a voltage gain, basically we defined that the voltage gain is dropped by -3 dBs, and -3 dBs is corresponds to basically 0.707 ratio. You can see 0.707 times of your voltage initial voltage gain, whatever it was, AV. We can define this as AV. So let's talk about this mid-range gain. So mid-range gain is what? Mid-range gain, if you see, the gain where for the frequencies where the gain is constant. So if you see over here, this is the range of the frequencies which corresponds to a constant gain, and that is where the gain doesn't change, it doesn't drops. So we call this as a mid-range gain, and this is the gain where your amplifier basically it operates. This area is where your amplifier operates, and this area is the area where when you decrease the frequency, when you decrease the frequency, so a reduction in the voltage occurs, right? So this is how we you should know about critical frequency and the mid-range gain, and the effect of when this frequency it decreases. So basically what would happen, that would have a reduction in the voltage gain, and the voltage gain, remember, it corresponds to 0.707 part of the gain, and this 0.5 in terms of the power. So because taking the log would give you -3 dB before this power and voltage gains. So the ratio is different. This ratio, we call this ratio power, is different from this one, but the result is the reduction in -3 dB. Thank you.